Okay. Okay, so hi everyone. We'll be starting with this week's summary and practice problems in this course, Microprocessors and Microcontrollers. To begin with the summary. Okay, there's one more problem. I need to have my video there, and there's no video on screen. Oh, no, I guess there is. Okay, okay, I'll start it. Oh. Hi everyone. I'm Liza, one of the assigned TAs in this course, Microprocessors and Microcontrollers, and we'll be starting with summary of week 6 lectures. So to begin with summary, first of all, Professor talked about the addressing modes. I think most of the addressing modes you will be familiar with from the 8085. So just a brief intro. Yeah, so first addressing mode is the register addressing. And okay, so by what you know by now from the knowledge of 8085, what would be the register addressing mode? Can anyone answer? Am I audible?
Yes, ma'am.
Yeah.
May
So hmm,
okay. So register addressing mode means either the source in any instruction, either the source or the destination. One of the two will be register, CPU register.
yes. So one of the either source or the destination would be the CPU register, and examples would be move
Example
R0,
is
comma A.
MOV, yeah, A comma any register of that
Yeah.
register bank.
So, okay. Yeah. So, if you want to move the contents of, let's say, accumulator is okay. If one of the operands is accumulator, you know it will work. So, if I want to shift it, copy the contents of one of the registers, say R7 and R4 to R4, what would be the appropriate instruction?
What is the source, ma'am?
Let's say I want to, source would be R4.
R4. So MOV 4 comma 7. This will be the
Yeah,
instruction.
correct. Right? As
Yeah.
sir told in class. Okay. So, is everyone okay with this? You can't write move R4 comma R7. You write it as move 4 comma 7. Or if the source is R4, then move 7 comma 4. Right? So, next is the direct mode. What is the direct mode? In direct mode, you specify the operand, the data itself in the operand, right? For example, if you want to uh, move or copy, or you want to move a number, let's say 60 to accumulator, you write directly move a comma 60h, right? Okay. And what is the difference between the instruction when you want to move data or you want to move the, since we have 8-bit addresses here, how do you differentiate between data and the address location in the
if we
instruction?
if we want to tell the data, then we have to put one hash in front of that. And if we want to mention as that as address, then we have to put one zero in front of that.
And how do you differentiate between hex number and decimal number in instruction itself?
After hex, we have to put h,
After the
hex
number,
number after the number.
right? All
Yeah.
right, perfect. Then we have register indirect mode. What is register indirect mode? The address of source or the destination is specified in the register, in one of the
Register.
registers, right?
Yes.
You load the value of address in one of the registers, and then you use that register as a pointer, same as 8085, right? So register indexed mode is new somewhat. How do you use register index mode? You for the programs, uh, when you want to access the locations which are consecutive, you use this register index mode. Now, if I had pen, I think you guys must be having your notes, right? So if you can open your or keep your notes with you, that will be easier for you guys also to understand. So in register index mode, you load the data pointer with some address value, and you load the number of locations that you want to access in that program in the accumulator, right? So and then you can use that value of A. Um, Can you use that uh, value of A to as indexed value that will be added to the data pointer address to access the consecutive addresses. For example, if you are loading data pointer with let's say 4000H, the address of the location from where your data starts is 4000. And if you load your accumulator, and if you load your accumulator by the number of addresses that you want to access, let's say that's 5 here. So you'd say move data pointer comma hash 4000H. Then your next instruction would be move a comma hash 5. Then move C. Okay, yeah. So what is the difference between, I mean, what would be the instruction to move the contents of the location pointed by this data pointer? And if you want to move the contents to accumulator, there you have different kinds of move instructions, right? MOV, MOVC, MOVX. So which one would you use here? I mean, it's or indirect question. What's the difference between move C, and move X? Can someone answer? I have loaded the address of the first location with my first data, right, to the data pointer. Then I have loaded the number of locations in accumulator, and now I'm going to use the indexed this addressing mode to get the contents of the address locations pointed by this data pointer plus the index value of A. So what will be the instruction if I want to move that content of these locations to A?
Sorry, can you repeat the question?
I said I have loaded the address location's address in data pointer, and I have loaded the value of number of consecutive locations that I want to have access for in accumulator. Now I want to move the content in pointed by this data pointer plus the indexed value of a. Are you getting what I'm trying to say? If data pointer is 4000, and let's say for now a is 5, and I want to access the content of this location pointed by 4005. Do you remember what was the instruction to move the content of
Ma'am,
4005 to A? Yeah,
it will be move C A comma at the rate A plus DPTR.
yeah. So you remember the instruction. Now I'm asking is, how do you know or how do you differentiate whether you are going to use move C, or move X? I mean, here you're using move C. You are correct. Absolutely correct. But how did you choose you're going to use move C?
Uh, Ma'am, when we use any data pointer, any external memory pointer, data pointer, that time we have to use move X.
Okay.
And here, as we are using data pointer plus accumulator,
Yeah, we understand this is index mode, right?
index
Addressing
mode,
mode.
yeah, yeah. Uh-huh.
I'm just asking, leave this one. I'm asking what is the difference between move C, move X, and move? Like in previous addressing modes, in let's say direct addressing mode, you said if I want to move the contents of location 60 to A, you'd use MOV A comma 60H, right? Correct.
Yeah, ma'am. Yeah, yeah.
So I'm just asking, why are we using move C here, not move? Okay, first of all, the indicator should be there. The address was 8-bit, right? Which means internal RAM, correct? So for the
Yes.
addresses which are for internal RAM, you use move. Okay,
Okay.
and to differentiate between external RAM and ROM, we use move C and move X.
Yes.
Yeah, that's the difference. No, 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 no. Okay. Move X is for external memory.
Yes. When we use the DPTR that time.
Yes, move X is for external memory. Move is for your internal RAM, and move C is for your internal this code memory, ROM. That's the difference.
Okay, okay.
Okay. Okay. So yeah, I guess you should write it somewhere because I don't know where I'm going to. Should I write it in here and then send you the PPT? Would that be okay? Or are you guys taking notes? Or is it not necessary?
As you feel
I mean,
you
I
can do
can
it. Yeah.
write.
Yeah,
uh,
if
it's-
possible, then you can obviously write.
Okay,
Or
sure.
I'm
I think
writing.
I'll write it here
If
and
possible,
then
otherwise we writing.
anyways, I write always, right? It's just you won't be able to see. And I'll share the PPT.
Yeah, that's why it's not possible, then leave it for today. We are writing now.
Okay,
Yeah,
sure,
you
sure.
just tell. Yeah, you just tell. We
Huh.
are writing. Yeah.
All right. So yeah, that was the register index mode, and I hope now you know the difference between move C, and move X. Then we have accumulator register. Any specialties about the accumulator? I think we discussed this last time also. So accumulator is the only register that can be used to exchange data between internal external memories, right? So that's that. Then there was something about the addressing of accumulator. Uh, accumulate. I mean, all the SFRs can be. What do you say? Can be accessed by their names as well as their addresses, right? So accumulator can also be accessed through its name. You can write move a comma 00h, or you can write move e0h comma 00h. E0 being the address of the accumulator, right? Then SFRs, all the SFRs, I think they were discussed. What else? Instruction format, I guess you guys know what is the instruction format. You have a code for the opcode, then you write whatever the operand is. If operand is to be specified, and if it's not, then the whole instruction will carry its own code, right? Then stacks. I think this was the problem last time. So, and the reason I was also confused was because of 8085. Now, if I could draw. Uh, when you push some value in stack uh, through the stack pointer, the stack pointer will be incremented, not decremented. First. Second, it's not like 8085. I mean, it's difficult, but you'll have to remember because since stack in 8051 is in your internal memory, it is 8-bit, and stack pointer is 8-bit long register only, not 16-bit as compared to 8085. So I don't know. It's going to increment only after the push. The logic is same, last in first out, but the memory location will be incremented. The value of the stack pointer will be incremented, not decremented. Okay.
Yeah, ma'am. I was also confused, but I have read these slides now. That's I have
Yeah,
cleared my
yeah.
confusion.
I was
Last
also,
time,
I mean, I didn't pay attention while
and that
making
time,
notes, but yeah.
yeah, yeah. That time in 8085, it was incremented by two, but here
Yes.
by one. That was the
Yeah.
confusion also.
So by two and by one can be understood easily now, right? Since their stack pointer was 16-bit, here stack pointer is only
8 bit.
8-bit
Yeah.
because of the only difference between 8085 and 8051, that is 8051 has internal memory,
Yes.
right? And
Yeah.
internal memory is 8-bit wide. And since stack is in that 8-bit wide memory, stack pointer is 8-bit register to indicate the address of the top of the stack. Alright.
Yeah.
Then
Even though
mhm.
stack pointer is 8-bit wide, um, if you want to push the return address could
Yeah, you
be
can
16.
then yes, then 2 bits will be bytes will be used, right?
Yeah, so in such cases, we need like the stack pointer will be incremented by 2 when you are
Ye-
pushing the return address.
Yes, obviously. All right. Okay. Then What do we have? Exchange instructions. You have XCH, XCHD. Can anyone tell me what is the difference between XCH and XCHD? It's a normal exchange instructions. If you don't remember, I can explain. So exchange would okay. So what would be the instruction be like? Let's say you have an instruction XCH A comma 25H. What's the meaning of this instruction?
Ma'am, only if we use only XCH,
Mm-hmm.
then it will exchange the data in between the operands. That is, if I'm writing XCH A comma R1, it will exchange the value in between A and R1 register.
Content of R1.
Content of R1. Yeah. But if we use XCHD A comma R1, then
Mm-hmm.
it will exchange the digits. Means lower
Which
order
digits? Yeah.
lower order 4 bits will get exchanged.
Yeah. So lower nibbles of so
Lower
that
nibble, yeah.
lower nibbles of accumulator and the register specified will be exchanged. Right? 4 to 7 won't be affected by this XCHD instruction. And what about XCHA comma at the rate R1?
It will exchange the value in between A and that memory of that means R1
Content
contents of
to which
that
R1,
memory,
yeah,
yeah,
memory location to
so
which R1 is pointing to,
pointing to, yeah, yeah.
right? So, yeah, exchange instructions with this. Then we have bit oriented data transfer. As you can know by now that there are many bit lot of locations are bit addressable, and our SFRs, some of the SFRs, some all are bit addressable. So we have we can have data transfer for individual bits also. Examples being PSW, you can affect the flags. Then you have what is the address of bit addressable memory in RAM? 202
202 2F, ma'am.
202F, yeah, that is bit addressable. So we can have instructions like set B, and you specify the bit or the address of the bit that you want to change, clear B, complement. So yeah, such I guess there are 12 instructions for 8051 for the individual to affect the individual bits. I don't have the list here, but yeah, you guys can write it down and search what those 12 instructions are. But mostly you use set bit, clear bit, complement. Yeah. Then you have data processing instructions. Um, Arithmetic instructions, these are similar to, I mean, almost similar to what you have already learned in 8085. But yeah, so since they might seem similar, you just need to pay attention to what differences are. So, how, uh, for example, arithmetic instructions, there we had add, right? Here we have add and add C. So, what's the basic difference of add and add C?
In case of
Add
add
works.
in case of add instruction, only the content of accumulator will be added with that other byte,
Yeah,
and
yeah,
in
the
case
operand.
of add C, one carry will be added with that. If any previous carry generated.
Yeah. So it's like if you can, I think you can relate to half adder and full adder, right?
Yes, ma'am. Yeah, yeah.
So add C is like full adder, add is like half adder. Add C will include the carry if carry was generated in previous addition operation, right? So for addition, we have this distinction, and what all flags are affected by these instructions? Add instructions. Will carry flag be affected
Yes,
for
ma'am.
add?
Carry will be affected if the result is greater than FFH.
Yes, if the addition of MSBs is
Greater than
generating a
FF.
carry. Yeah.
Yeah.
Auxiliary carry,
And
if bit 3
auxiliary
is,
carry is also affected if there is any carry generated from bit 3,
yeah.
bit 3 addition. And overflow flag, I have a confusion in this flag also. Yeah,
What
not
confusion?
clear basically. Means
Hmm.
how it
So,
works, I'm
okay.
not clear it is properly.
So basically, it was given that if there's a carry out of D7 MSP and not out of D6, there will be an overflow, right?
Uh, yeah,
Confusion is where
means only
I think, haha,
if there is a carry out of bit 7 only, not from bit 6, or vice versa. What is that vice versa?
if there's a carry out of
Yeah,
D6 and not out of D7, but that can't be overflow. Yeah, or let me see if I have
yeah.
example. Um, I'm not able to re Let me see if I can find example later, right?
Okay, ma'am.
I think with example can be understood better. Okay. Yeah, so that was add. Then there was a program for addition of numbers. I don't know how I'm going to explain it. But did you understand the program that sir explained? He took 16-bit numbers and they were added and stored at some location that was given.
Yes, ma'am. I have seen that, but there I
Okay.
think that overflow flag is 0 there in that.
Okay. I'll check.
Hmm. In
Overflow in
that
this
case, I
example.
think in means
Huh.
I have a confusion after seeing that. Yeah.
Confusion regarding overflow flag or the general
No, no, that
program
overflow flag. Yeah, that overflow
in that
flag.
example.
Yeah,
Okay,
yeah,
I'll
yeah.
I'll check.
Mm-hmm.
Okay. So that was addition. Then you have subtraction. For subtraction, we have only one instruction, unlike add. And if the instruction is SUBB, a comma, whatever your operand is. So what will be the operation if the instruction is a comma subtract a comma some byte? The operation will be subtraction of, A minus the byte, the operand, minus the carry if there was carry, right? And the result will go to accumulator, correct?
Yeah, ma'am.
Yeah. So since we don't have any distinction between subtraction instruction just as we had for addition, and carry is always subtracted from this during this operation, so it is recommended, it is suggest, you should clear the carry first so that there's no remaining carry from any other previous operations. All right.
Yeah, ma'am.
Okay. So then we have other other instructions like INC, increment and decrement. So increment and decrement work as arithmetic instructions only. They just require, like, if you want to increment accumulator, INC A, increment some number, INC that number, increment data pointer, INC DPTR. Decrement, you can decrement accumulator or any number or anything, but you can't decrement a data pointer. Your data pointer is just right. It's just the way 8051 is built, is programmed or designed. You can't decrement the data pointer. Okay. Then these increment decrement instructions cannot affect the carry. They affect the zero flag only, right? Then there was a program to increment 16-bit word. Does anyone have any confusion in that program? Okay. Then multiply, simple instruction, MULAB. What will it do?
It is
Where
multiplying
will the result go?
uh, the output higher nibble, no, higher byte will go to register B, and
B,
lower byte will go to register A.
A. And the instruction is as it is
MULAB.
mentioned, like this only. You can't change it. Then similarly division, div a b, it will divide a by b, and the results will be, since in division you have quotient and a remainder, the quotient will go to accumulator and a register, and remainder will go to uh, b. Just a minute. Yeah. Okay. Uh, is division clear to everyone? Uh, yeah. Okay. Then we have decimal adjust. DAA. What does it do? Okay. So decimal adjust is the instruction when, let's say, I mean, you're doing your operations in your mind in decimal numbers, right? But the processor is taking it as hex numbers. So after arithmetic operations, it will give you answer in hex numbers. So to get back your, I mean, if it is required to get back the result, and I mean to the real world, you have to adjust the operation result that the processor is giving you to make it into get back into the decimal value. And for that, this decimal adjust is used. For example, I've taken just the same example. I think it was clear there, but let's say you want to add two numbers, 23 and 29, but you're giving them as giving input these 23 and 29 are input as hex numbers. So the result will be in hex also. So 23 hex plus 29 hex is giving what? 40?
4cx.
Yeah, 4c hex. But your actual answer should be
52 in decimal.
52 in decimal. So, and this is just one example. You can take any number, you can try checking them that to get back to the decimal, you have to add 6, right? So this decimal are just by its the definition, the way the instruction is created and the processor is designed, it will do what? It will add 6 to the result. The hex result that we got, it will add 6 to it and give out the decimal answer in decimal. Okay. Uh, yeah. Next is logic instructions. So same and or XOR not. All of these are logic instructions. Clear, rotate, swap. Swap is new. We can discuss that. So bitwise logic instructions can be for AND ANL, for OR ORL, XOR XRL, complement CPL. Then we have rotate rotate left through carry, same as we did before. What does swap do? What does swap do?
Swap the nibbles of the accumulator.
Uh, okay. Yeah. So a lone swap will just swap the nibbles, lower and higher nibbles of the accumulator. Then, yeah, one important thing, they don't affect the PSW. Right? One thing to remember. And yeah, so then we have program flow control. You have different kinds of jumps, conditional jump, call and return. As we call and return, same as you learned in 8085. And conditional jumps, they are, I mean, you have different options here. So yeah, so unconditional jumps can be of the following types, as you can see, S jump, L jump, A jump, and jump at whatever the address is indexed to. So S jump, the instruction would be like S jump and some address, and the address range can be from for S jump. It's a short jump. You don't have very huge range. So it can go from minus 128 to plus 127. So this can be the range for this instruction, right? You can't, you can't give it any random address out of this range. Okay, there's a reason it's called short jump. Then we have L jump, long jump. The address can be whole 16-bit wide, which means you can access the whole 64K memory using this L jump. Anywhere you are, you can go to the other end of the memory through this L jump. And most of the times it is recommended to use L jump yeah, because of the range. Then we have A jump, uh, which has address can be how many bits wide. Anyone?
Please repeat the question, ma'am.
Uh, how many bits wide range of addresses you can use for absolute jump?
11 bits.
11 bits, right?
Yeah.
So the addresses that can be accessed are 2K,
Yes,
2
2K.
to the power 11,
Yeah.
2048 addresses. Then you have jump. You load values to data pointer and accumulator, and you can use this jump condition like this. Directly jump to the address you're giving through a and data pointer. This is the index jump. Then yeah, then there were some programs. Does anyone have any confusion relating to the programs that were discussed? I think there was some infinite loop example.
Just one point to add related to the recommendation you have made for the long jump and short jump, madam.
Mm-hmm.
So my understanding is short jump we use to save the memory. So memory is costly. So we need to save 1 byte. And
Mm-hmm.
in the controller applications where we don't jump
I'm sorry, I'm not
condition
able to hear you.
where the jump will be within certain range, within say the 120. So in
Uh,
controller application,
Ananta,
okay to have.
your voice is not really clear. I wasn't able to hear.
Sorry, ma'am. Is it okay now?
Yeah, it's okay now. Yeah, please continue.
Okay. So no, what I wanted to say is like from my understanding in controller applications, right?
Yeah.
Uh,
For
uh,
short jump is for to save the memory. Yeah.
yeah, save the memory, and many a times we may be jumping within this minus 128 and plus 127. So if it is a microprocessor related application where we need to really jump too far, that time the 16-bit address may be useful. But in controller application, uh,
Yeah.
uh,
Obviously, it is according to the application. Yes, it should have had mentioned that. It is obviously if your range if the location that you want to jump is not very high, obviously you won't be using L jump, right? I should have had mentioned. Yeah, is that all?
yeah, that's all. That's all.
Okay, thanks. uh okay, so those are unconditional jumps. Then you have conditional jumps. I think most of them you're familiar with. Jump if zero, jump if not zero, jump if carry, not carry, jump if bit is set, jump if bit is not set. Then this JBC is, oh, Okay, there's a typo there. Should be bit. So jump if bit is set and then clear the bit. That's, I think, clear enough. Then you have the CJNE conditional jumps. There are a variety of them. I think if you look up for a table, you'll get all the CJNE instructions. So what it does is compares the value of A and the memory, the whatever the operand is, compare the values and jump if they are not equal. Compare and jump if not equal. CJNE. Okay. So that's that. And then we have call and return, similar to how we had in 8085. You call if there's a call instruction. Only different, it's similar to jump instruction. Only difference is the program counter's value is uh, pushed to the stack before the branching is done. I mean, wherever the call instruction is supposed to take the processor, before that, uh, this PC value is pushed onto the stack. Return is also similar, but then the program counter value is popped out from the stack, right? So yeah. Then there was an example of jump table. Is it fine with everyone? A small program to the different cases to where the program can jump to according to the requirement of the programmer at that time. All right, taking it as clear. And yeah, so initializing stack pointer, as we discussed last time also. What is the default value of stack pointer is 07. So let's say if the default value is 07 and you do not initialize it to any other different value, and some value is pushed onto the stack, where will be the value pushed to and what will be the value of stack pointer?
Into bank one.
No, I'm asking address. Yes, blank one. Leave blank one. Let's say I should have written 07H. Let's say the stack pointer currently is at 07H and you push about data onto the stack. Where will be the data stored and what will be the value of stack pointer after the push instruction?
Stack pointer will be incremented by 1 and the value will be stored in 08. And
And
after the
value of
push,
stack pointer will also be 08.
yeah, yeah.
All right. Yeah, I've written it there. Okay, so yeah. Next is delay. What about delay? So yeah, you know how to create delay with the loops, right? And there was this example to link LEDs, alternate LEDs connected to this port 1. Is there any confusion regarding that program? How do you create delay or anything? Then there were 2 or 3 programs, move string. from code memory to RAM. Then how to create pulses of different duty cycles. What is a duty cycle? Anyone?
A duty cycle means particular operating time of that particular, you know, device or component.
So there'll be a pulse,
There be a
first of all.
pulse, yeah. There be a
Yeah,
pulse. So the
pulse means there'll be,
on period
yeah,
of that pulse is that duty cycle.
not on period. The time for which it is on divided by the time period of the pulse
Pulse.
is the duty cycle.
That much percentage.
Yeah. Okay. I think it's everyone clear about this? What is a duty cycle? Okay. Then we have timers and counters. So how many counters are there in 8051?
Two timers,
Two
counters.
timers, T1 and T2, T0 and T1. Sorry.
Yeah, T0 and T1.
Okay. T0 and T1, there are two timers. Then these can be used as, I mean, timers, just count the time, and counters, count the event, right? So how do you distinguish between, I mean, there are these pins T0 and T1 on this 8051, right? How do you distinguish whether your, I mean, the question can be asked in two ways. These timer pins can take up, they require clocks because they're going to count, right? There is time involved, so there has to be a clock. And clock can be fed in to these timers internally as well as externally, right? So how do you differentiate between a timer and a counter? That depends on what the source of the clock is. Okay. So, how to say this? So, timer, the distinction is not very, I don't know, defined, I'll say. But works as timer when you're only interested in the amount of time that has been expensed, right? If you are asked to, let's say, do something, count the number of cars that are being passed on the road, and you're standing there, and you're asked to count the number of cars for 1 hour. Okay. You are deployed on some road and you're asked to count the number of cars that have passed for 1 hour only. And after the 1 hour gets over, you are free to go and you have your number of cars, and yeah, the deal is done. On the second hand, you're asked to count 50 cars no matter how much time it takes. Okay. In both the operations, the output is number of cars. Only the difference is uh, whether you're interested in count or you're interested in the delay or time, right? In first case, you are counting the number of cars, but only for the defined period of time. After 1 hour gets over, it doesn't matter you counted 20 cars, 50 cars, or 100 cars. You just need to count it for 1 hour, which means there's a delay of 1 hour. And through that delay, whatever is the operation that is to be done, you're doing that. In the second case, You're only interested in the number of events, number of times or number of cars that have passed. So you're acting as a counter. Clear? I mean, I'll tell you how it
Yeah.
relates to 8051.
Yeah.
Okay. So, in first case, your time is fixed, which means your clock should be fixed. Doesn't matter if car is coming right now. After all the cars are coming every 2 seconds, or one is coming right now, one is coming after 10 minutes. Doesn't matter, right? You just need to have precise knowledge of how much time has expanded, which means your clock should be fixed. And from where do you get your fixed clock? The clock of the processor. It has fixed clock, right? So whenever the pins are getting internal clock, they function as timers or delay generators. On the other hand, when your clock is not fixed, let's say for every car passing, your clock your clock gets low when one of the cars passes, right? And it goes high after it passes. So whenever the car is going to pass, the pulse will go low. The signal will go low, and that will create a count for you. The number of times the signal goes low, that will create a count for you, which means the clock does not have a fixed frequency, right? Event can happen anytime. There's no restriction on events. I mean, if there was a restriction on events, then timers and counters would be same. Am I articulate enough? I don't know. All I'm saying is, for the counter, you need not to have any restriction on the frequency of the clock. Your clock being the signal of that event occurring. I mean, you've gone to stores, right? Any malls or anything. They count you. There are those panels, and whenever someone crosses the panels, the counter increments by one, or how many people are crossing. That is for them to keep track of the footfall in the mall. There they use, and there's no restriction that only after 2 seconds someone will pass through the door. Someone can be entering simultaneously also, and there might be times that even an hour has passed and no one has entered. Eating. Say
Yeah,
yes,
ma'am.
no,
Yes, ma'am.
anything.
Yeah. It's
Yeah.
clear, ma'am. Yeah.
Yeah, so when the operation is as a counter, the frequency need not to be fixed. And for delay generator, the frequency has to be fixed. So the clock is always internal for the delay generator. Okay. Then what else? So how do you initialize, or first, so the registers used for the timer and counter, I wanted to draw T mod and T con. Now I can't. Okay. Okay, so these are the registers. The timer registers are how many bit wide? TH0, TL0.
They are
Huh?
4-bit, right? Each.
No, I mean there are no 4-bit wide registers.
No, no, total 8-bit actually.
8-bit for TH0, 8-bit for TL0. So the total timer T0 is
Six, 16-bit.
16-bit. It's not one register, but the two registers make up for the one timer.
Yeah.
Okay. So TH0 is 8-bit, TL0 is 8-bit, TH1, TL1 all are 8-bit registers. Tmod is 8-bit, Tcon is 8-bit. Okay. So yeah, both are 8-bit wide. Okay, so Tmod, timer mode register. If you have it in your notes, that will be good. So Tmod is a register to, as the name suggests, to decide which mode you want your timers to be working in, right? So bits 7 to 4, 4 to 7, or 7 to 4 are for timer 1, 1 to 3 are for timer 0, and MSB, the D7 is gate for timer 1, counter timer, counter slash timer. Actually, this should be written as C slash T bar because of the operation of the bit. For if this bit is high, it means the timer this is working as counter, and if it is low, hence T bar, it will work as timer. Then M1 and M0 to identify the modes in which the timer is working in. Then gate. Gate is yeah. Since we started late, we can end it late, right? Let's see. Okay. So gating, I think it wasn't that clear. I don't know. So let's see what this gate bit does. So for that, we need to understand how this timer works, right? Whenever or whatever mode it is working in. So for that, just a minute. For that, you need to know what is hardware control and software control. Okay, let's start again. Have it. Okay, so how does a timer work? Uh, it can produce delay, and you can produce delay using NOP instructions also, the way you did in 8085. Remember, you write NOP, put it in a loop, and while the loop is, I mean, the counter doesn't go to 0, the NOP instruction will keep the MUSI ideal. Well, not ideal. Uh, MUSI is uh, busy in implementing the NOP instructions in that loop. So, to relieve processor during the delay, I mean, it's the delay, but still the processor is busy. So, to relieve it of that, this timer is used. Whenever there is a requirement of timer, the processor will ask the timer to count until whatever time is required, and then whenever it finishes, it goes back to the processor and will inform it that whatever time was dedicated has been passed. And the advantage is that for this mean time, for the time that it was counting, uh, the processor was free, right? Hmm. Yeah, that's that. So, And one more distinction. The way we use this software delay to put NOP in loop, what do we do? Uh, Initialize a counter number, and it will count down to 0, right? But in these timers T1 and T0, the way they work are they are count uh, count up timers. Remember the expression? Yeah. So they count upwards. They are not decremented. So if you load a value, let's say 0.5 in the for the counter to count, uh, it will count upwards. Like it will go to 6, 7, 8, 9 up until FF instead of 43210. That's one distinction. Then okay, so how it works is you load the count. Okay, let's say you're loading 05H, and then what? You have to apply a clock pulse. You apply the clock pulse and timer starts counting. It's the value starts incrementing since it's a count up counter. Yeah, so if I'm loading 05, it'll the 05 will go to I mean the registers are TH0 and TL0. Timer 0 is used here. And I'm loading 05. So where will 05 go to? Anyone? Okay. So if I'm initializing the timer with the value uh, 05, this TH0, obviously higher byte, will get 00, and TL0 will get 05H, my count. Okay. So, and the after the clock is applied, the timer will start counting, and it'll count from after 5, it'll count from 6, 7, 8 until FFFF. Okay. And once it reaches FFFF, the next clock pulse will do it what? Reset the timer to 0000. And once it reaches to 0000, it will go back to the processor and tell it that it has counted whatever it was supposed to count. And basically, it sets the overflow flag. Okay. During that count FFFF2000, it sets the overflow flag, and that's how MUSI knows that the delay has been completed, or the time whatever it was supposed to count is completed. Okay. Any doubt? Are you guys there?
No, ma'am. Not doubt. You may start.
Okay. Then that's that. And I just told you that first thing to do is load the counter. But with what value? You need to count the value, right? And it's not like before that you load 5 and the loop will go 5 times and it will count 5 counts. It is counting upwards. It will go from 0005 until FFFF, right? So if you really need to, I mean, if the actual count was 5, then what would be the value that should be uploaded in these registers TH0 and TL0? Can anyone calculate? Let's say I want to count 5. I mean, 5 iterations are to be done, or 5 events are to be counted. What value should be loaded in TH0 and TL0? because you know after it reaches FFFF and then goes to 000, then only the count will be complete. So you can't load 05. You'll have to count backwards, right? Okay, so the value to be loaded will be FFFF minus the count that you're supposed to count plus 1. Why plus 1? Because only after FFF goes to 000, then the overflow is set. Overflow flag is affected, not at FFF. Okay, and that's that. Any questions on T mod? Or how the value is? Hello?
No, ma'am.
Okay. So I'm not sure if TCon is was discussed in this week's lectures. Is it there in next week's lecture or?
Yeah, yeah. It is in session 7, week
Okay.
7.
So we need not to discuss it now. T mod was discussed, but I guess the questions are not there for T mod also. Did you have T mod questions in assignment 6? Because we're running out of time. Okay, let's have a brief discussion. For these timers or counters to count, there has to be a what do you call software control. Compulsory software control has to be there. Your software has to allow the timer to uh, count. Hardware control is optional. Okay, so these what is it called? TR. Yep. So in TCON register, you have TR0 and TR1, which TF0 and what am I saying? TR0 and TR1, which are when set will allow the timer to count, and which are when 0 will not allow the timers to count. Okay, these are the software controls. And why did we have to introduce software control? Because gate is used to enable or disable the hardware control. Okay, so whenever gate is gate bit is set, the counting is controlled by your INTX pins, INT1 or INT0, depending on which timer's gate bit is set or not set. So whenever it is high, the counting is controlled by INTX. For example, if you want to start a count with a button, it's like having a control which is very user friendly. For a programmer, you can control your timers with your program, right? You can code it, but if the user is not a programmer, he just needs a uh, button to press, and so that the timer starts counting. So this gate is for that enabling of that hardware control. You connect your button to the INTX pins, and which enables if gate is set, which enables your that button to have that control of starting the count. But also it's not, I mean, it is necessary that your TR0 and TR1, the corresponding TR pins, are also 1. Because if they are 0, your hardware control cannot control or cannot start your counts. Just that point. And okay, I guess that's enough of timers and counters. I had more. Does anyone have any doubt in different modes M0, M1, M2, and M3? How they work?
Ma'am, please explain that M2 mode. Mode 2
M2,
actually. Yeah, mode 2.
8-bit timer counter.
Yeah,
Anyone
8
else
bit or
with
8 bit.
M0, M1? Everyone's fine with M0 and M1? Okay, so just for the sake of completing it, M0 is a 13-bit timer counter. It requires 8 bits of THX, X being can be 0 or 1 depending on timer 0, timer 1, TL, and 5 bits of TLX. Right? M0 is a 13-bit timer counter. It is very useful in your serial com whenever you do serial com. I don't know, it's maybe next week or next to next week. So yeah, it is useful in the serial communication, this mode. M1 is a normal 16-bit timer counter. All of the bits of TLX and THX are used. And hmm, I forgot to tell you, the timer overflow bit is called denoted by TFX. It's not your normal overflow OV, right? So these TFX bits in TCON register, when you do those lessons, you'll find the TFX timer overflow flags. Yeah, so M1 is a 16-bit timer counter. It can produce delay of about 64K. Then M2 is a 8-bit timer counter with a reload. Okay, so what happens is, let's say you want to keep counting. All of these other modes, M0, M1, and M3, are single, what do you say? Single modes. You load the counter value and they count until FFFF, whatever the value is. Count back to 0, overflow is generated, and they stop doing whatever they're doing. Only M2 is the continuous timer. I mean, by definition, M2 is 8-bit timer counter with a reload. Reload means whenever the timer finishes its count, the initial value that is loaded is reloaded into the registers and it starts counting again. Okay. So what happens is, initially you load your this in the value in both TLX and THX. Okay, let's say you want to load 08. You want to keep counting how many times 08 is happening. For example, I don't think I have an example right now. Let's say you want to count how many uh, groups of 8 people have crossed your entrance. Okay, so every time your timer completes 8, it has to be reloaded and count again. Okay, so what happens is initially you load both TLX and THX with 8, and from your clock you'll get clock pulse. Value is loaded, the timer will keep counting, and after, no, if you want to count 8, you won't be loading 8, right? You'll be loading FF minus 8 plus 1. FF minus 8 plus 1 is FF minus 7, which will be uh, FF minus 7 is 5, 8, 9. F9. or F8, whatever.
F9,
Calculate
ma'am.
what. Ha,
F9.
ha. So you load, if you want to count until 8, you load the value F9 to both THX and TLX. Once it reaches FF and goes back to 0, your timer overflow will be generated. But at that time, whenever the timer overflow is generated, I mean, I could have explained it with diagram very clearly. I guess I'll add the diagrams in the PPT before uploading them. Okay. So once TLX has completed its number of times from when it goes from FF to 00, a signal is generated for timer overflow, right? The same signal will be fed to THX also. The clock was fed to TLX. TLX kept counting because clock was connected to it. Once it completed its count, it goes from FF to 00. A signal is created for TFX, right? The same signal is fed to TFX as well as THX. THX gets the signal, which in a way, I don't know, identifies it as to reload the value of TLX. Okay. As your TLX went to 0, I mean, clock is still coming. Clock has not stopped. Once it reached
Means
00,
means means again that value, that F9 or F8 whatever, that will be reloaded to again to
TLX.
TLX.
Because THX was not disturbed through this whole time. Clock was only going to TLX.
Okay.
Okay.
Yeah.
TLX, initially it contained whatever the value it was having. It has the same value. So the signal that was for timer overflow, the same signal is fed to THX also.
Yeah. Understood, ma'am. Yeah.
Okay. That is mode 2. Then mode 3 is your two 8-bit timers. I don't know if it was discussed in class. So what happens is you have 2 16-bit timers, right? In mode 3, you get two 8-bit timers. You kind of split your timer 0 or 1, I don't know. You split your timer 0 into 8-bit timers, which means TH0 will act as a single 8-bit timer, TL0 will act as a single 8-bit timer. Yeah, and TL0 will be getting its clock from whatever the input stage was. TH0 will get the clock from internal clock. I mean, they have to have, and if they are two independent timers, they have to have two independent clocks. So one of them gets from, as it was getting from previous timer modes. TH0 compulsorily will have a clock from the internal clock. Then what about timer overflows? Uh, TL0 will get timer overflow of timer 0. TX0 will get or borrow the timer overflow of timer 1. And yeah, they'll interrupt the processor whenever they complete their timer operation, delay operation. So the question remains, if I mean timer 0 is completely occupied, right? TL0 is one, has become one timer, TH0 has become another timer. Timer overflows of both timer 1 and timer 0 are occupied. What is timer 1 doing? So timer 1 can act as independent timer. I mean, it's like a timer from which no output is expected. I mean, no output is expected in on our end. It can be a timer for processor internally. It doesn't have to. What do I say? It doesn't have a timer overflow flag, but it can still keep working on as timer internally. But it has lost, what do you say, connection from the outer world because its timer overflow is being used by TH0. I don't know if you understood it because if I had diagrams, I would have. Huh. Anyways, I'll add the diagrams in the PPT and you guys can ask me questions next time. I don't know. Is this M3 mode discussed in next week's class?
Yeah, ma'am.
Okay, then it's okay. Okay. I think we'll take 10 extra minutes and we might be done with this problem. Okay, fast. Increment and decrement work as which instructions?
Logical,
No.
arithmetic, arithmetic.
I mean, incrementation and decrementation is done by addition and subtraction internally, which makes them arithmetic
Yeah.
instructions.
Option B.
Option B. Everyone okay with this? Is anyone
Not
there?
addition. Is it not addition only, madam?
No, it's increment and decrement.
So decrement, can't it be done using 2's complement addition? I'm not sure. I'm just asking.
I mean, there's a separate instruction for subtraction, right?
Yeah.
It is done using two's complement addition only internally, as NUP understands, but we see them as different. I mean, addition is arithmetic instruction, right?
Yeah, that's why I was confused whether
Hmm.
like.
Answer should be arithmetic.
Okay.
Internally, subtraction is done using two's complement, but yeah, arithmetic. Okay. Next, which of the following instruction is equivalent to move A, comma, hash 55H?
Option C.
Think again, a little more.
It should not be C and D.
So our instruction is move A, comma, hash 55H. Hash means it's a number, not a address location, right? So it can't be C and D. And then you have to remind yourself what
B.
address of accumulator is. That is E0. So
Yeah.
B is the correct answer. Okay. Next. Which of the following RAM locations are bit addressable?
Option A,
Option
20H
A.
to 2FH.
Yes, option A. Okay. So what is going to be the content of accumulator after execution of following program? First of all, this value 54 is moved to accumulator. A has 54. Then swap A instruction is implemented, which will do what? Swap the nibbles of the accumulator, which means after swap instruction, A will have 45H. And then there is RLA, which is rotate left accumulator. After rotating, if you want to do or after rotating, you'll get 8A.
Yes, ma'am. It's 80.
Yeah.
Yeah.
Everyone doing? Okay. The answer will be 8A. Clear with everyone? Yes, no.
Yes, ma'am.
Okay. Next. Yeah. Mm, okay. For this, you need to draw T mod. Can you guys do it? So T mod has 8 bits. First four, 7 to 4 for timer 1, 3 to 1 for timer 0, and the values that you are entering is 2 and 0, which means T mod will have what? 2 is 0010 and 0 is
Ma'am,
0000.
timer 1 is acting on mode 2. Number A, I think.
Mode 2, yes. And
Timer
timer
1.
0,
Timer 1 is selected. Left side is timer 1 and right side LSB is for timer 0 and
yes.
MSB is for timer 1. So timer 1 is selected and
In
in
mode
mode 2.
2.
Yeah,
Okay.
A,
Yeah.
option A.
So A is correct, everyone. Please say yes or no. We are a small group of people. Okay, moving on to next. Identify the operation performed by following program. First of all, A is cleared. Then you move 60 to register 1. Then you move 16 to register 7. And then there's this instruction move at R1, comma A. Increment R1, decrement and jump, if not 0, R7 to again. So, I don't know. Okay, so first instruction is clear A. A will be 0. Then you move 60 to register 1. You load. Okay. Then you move 16 to R7. And what is this instruction doing? Move at R1, comma A. A was already cleared, which means to whatever location R1 is pointing to, you are moving 0000 because A is 0, right? So you are clearing the RAM location wherever R1 is pointing to. You increment R1, decrement R7, and move back to again until R7 is 0. So what is it doing? First location is whatever this 60 location is cleared. You increment R1. R1 is now pointing to 61. You decrement 7, which R7, which means R7 will now become 15. There's a loop, and all of the locations to which R1 is pointing to are being cleared. Can you understand?
Yes, ma'am.
Right. So, what will the correct answer?
Option B.
B. Right. Okay with everyone?
And just a point to note, in a hurry, we should not select option A because it's mentioned as ROM or OEM.
Yeah. Yeah. Thanks. So these registers are in RAM, right? So
Yeah.
Okay. Next question. Which of the following is not valid instruction?
Option C, ma'am.
Everyone knows.
Option C.
Option C.
DPTR.
Option
Ma'am,
C.
it will be DPTR na instead of DTPR.
Yeah. Yeah. Okay. Option C is correct. Okay. So this instruction SUBB A comma R4 is executed, then which of the following operation is being done?
A minus R4.
A minus R4.
Option C.
Easy.
Yeah, but
Uh,
it will be SUBB na sub
yeah.
A comma.
It should be SUBB. I'll correct the PPT and then upload it. Okay, so which of the following is valid immediate addressing mode? So three of them are wrong. One is correct. Which one is valid?
Option C, ma'am.
Option C. MOV
Okay.
comma hash 42H.
Then knock out why A, B, and D are wrong.
So, in A and B, there is no hash symbol.
And
Which
both
means
are
there's no
deep.
immediate value. It's not immediate addressing mode.
Okay, okay.
Yeah, you are correct. There's no hash value. Hash means there has to be a hash value, okay, number for it to be immediate addressing mode. Yes, that is why A and B are wrong. And D
For
because
DPTR, it
number.
will be at the rate sign.
No, 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 no.
Option D.
DPTR is okay. Only you can't have value
Oh, five
6897.
digits are there. Yeah,
Yes, you can have maximum of FFFF, right?
yeah,
What is the value?
yeah, maximum.
I forgot. Whatever the value is. And even in hex, 68975 is huge number. So maximum you can have FFFF. H. Okay, clear? Next question. So which of the following statement is true after execution of MULAB, multiplication? High order byte of result is stored in B when overflow flag is set to 1. Carry flag is cleared to 0. Low order byte is stored in A, or all of the above.
All of the above. Option D.
All of the above. Right? So D is correct answer. Next. So which of the following comes under indexed addressing mode? We just discussed it. Indexed addressing mode. I mean, it's the unique one, right?
Option D.
Option?
D for Delhi.
Not D for Delhi. It's B for Bengaluru.
C for Delhi plus
I mean, index addressing mode we just discussed in no last
Yeah,
time.
A plus DPTR. That one.
We were
Memory.
discussing it.
Yeah.
index doesn't mean the we are using that address symbol, right, madam? At R not comma A. So is it?
No, indexed means you're using this value of A accumulator as indexed value to add to the data pointer. Data pointer is indicating to some location, right? So if let's say value of data pointer, as we took the example earlier, if data pointer has value 6, let's say 4000H, and A is your 5H. So this move C at A plus, this instruction will do what? It will point to address which is the sum of A and DPTR, which means 4000 plus 5. This will indicate to the location 4005H. The value of A is indexed and used to indicate to a address. Yeah, that's how it is explained. That's the indexed addressing mode.
Okay.
You see, if you, I don't know, you sum over some values, right? And you use some index AI running from 1 to some number. And inside that summation, you have some, let's say, AIs. I don't know, I don't have pen.
So
I understand,
whatever
ma'am,
the
that, but is that comes under absolute addressing mode where we add offset. So I'm confused between the indexed addressing
Which
mode and absolute addressing mode.
absolute addressing mode means? Which one are you referring to?
It's again the same, the DPTR. Uh,
As far as I can remember, in index mode, you use value of A as an index for to have access to say multiple locations which are consecutive. Like you keep changing value of A and your DPTR will go from, let's say A is initially 5 and you put it in a loop. You can access locations from 4005 to if you increment A, uh, it becomes 6, then you can access 4006. You increment A again, you can access 4007, like that. A is acting as an index for the starting of the location where your set of data is present. That is why it's called indexed addressing mode. Absolute one, I think I'll have to check.
okay.
But this
no,
one is indexed.
absolute one is used for, I think, the jump branching instructions for that in that
Oh,
cases.
is he referring to absolute jump? That's what I.
That
No, no.
jump, absolute and relative jumps. That those
Then what?
absolute and relative jumps.
Uh-huh.
Those are addressing absolute addressing modes in that
Uh,
is there.
okay. But that's the name of the jump instruction. I don't think it's addressing mode.
Yes, ma'am. Is that are the jump instructions? The
Anant, was
branching
that you?
type of jump instructions.
Yeah. Anant, can you check?
Sure, ma'am. I'll check, ma'am. I'm
Mm,
a bit confused. I'll check and come back.
yeah, so I think you are referring to absolute jump because absolute addressing mode, even I don't know. Okay, but this one is definitely indexed addressing mode.
Okay. And the last one, option D, move at or not comma A.
Mm-hmm.
So what is that addressing mode for that?
This is that, what is register? Let me see. Oh, oh, oh. What is it called? Register indirect, right? Yeah, register indirect.
Okay, okay, ma'am. Thank you.
Yeah. You use that to indicate a location of, but in that, there is no role of indexing, right? Index means the value of index keeps incrementing, or there's a whole array of values that that index is supposed to have. So, do you understand?
Yeah, 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 ma'am. Yes.
Yeah. Okay. Okay. So, next question. What is the value of bits 4 to 7 of R0 after the following instructions are executed? Ask everyone. 04 is moved to R0, 11 is moved to A, and then XCH is implemented. What are going to be the values of, uh, what's going to be the value of, you need to specify the value of nibble of R0.
Zero
So
H.
XCH does what?
Zero H.
Mm-hmm.
Zero H. 4 to 7.
So keep in mind, this is XCH, not XCHD, right?
Oh, oh. CHD is we only put one nipple. Yeah.
I'm not
So if
able
it is
to hear.
XH, then it will be 1H.
Yes, so XCH does simply exchanges the values of A and R0, and the higher nibble of R0 will simply be 1. Correct? Mm. And what if the instruction was XCHD?
Then it will remain 0.
It will remain 0.
Yeah. I got confused. That's why.
Huh. Okay with everyone?
What is XCHD, madam?
What?
What is the abbreviation? XCH, you mentioned D.
XCHD. There's another exchange instruction, right? Exchange digits. This is exchange instruction. That is exchange digit. XCHD.
Okay,
Yeah. So XCHD will exchange the lower nibble of the operands.
okay.
Okay. So what will this instruction do? Add a comma hash 100.
Ma'am, what will be the correct answer of previous one?
Correct answer to the previous
C, ma'am.
one.
Come on.
Just a minute. It will be B.
Okay, ma'am.
Yeah.
It's C. It's C. Option C.
Yes, it's C. Everyone okay with the answer?
Yeah, ma'am.
Cool. Which of the following flags are affected by the instruction div AB of 8051? Oh shit. Okay, so correct answer is C.
Yeah, ma'am. Actually, overflow flag is not been affected by the IV instruction.
Yeah.
So the option is D, madam.
Uh-huh. Okay, this one. Correct order of execution when the interrupt occurs. And interrupts were not discussed, right?
No, ma'am.
Interrupts were not discussed. Okay, we can skip this question. I have more questions if you want to practice, or we can close now. We are over time. Anyone?
What today up to this, ma'am?
Huh?
What today up to this?
I have some questions like this. I don't know if you want to. I think we can go through them fast. Okay, so how many iterations will the following loop have? It is loaded with FF and R7 is kept on decrementing. So number of iterations will be
256 times.
256, yeah.
Option B, ma'am.
uh, really
It's 255, madam. Option A.
255. It's the conditional jump is decrement and jump if not zero. When it goes to zero, it's not going to jump back, right? 0 to FF is 255.
Yeah. That actually jumps to back.
Yeah. Okay, so the correct answer is 255, which will give you the answer to the next question.
Yeah,
Answer
just to
is
add, if it is
uh-huh.
move R7, yeah, okay, see, sorry, okay. Okay, sorry, I didn't see this question. Okay, from the previous I
Yeah.
was about to add the current
So this
position
is the next
actually took.
question.
Okay, okay, ma'am, thank you. Sorry.
How many iterations?
Now it is 256, ma'am.
Now it's
Because it starts from 00.
okay with everyone?
Yes, ma'am.
Okay. Uh, I think you can do these. Okay. First, what will be the status of carry flag and overflow? What all flags are affected by add when you add it with 7F?
Carry flag. Ma'am.
Carry flag and no overflow flag, right?
Sorry, ma'am, can you come again?
There will be a carry. Or will there be? Uh, no, there won't be a carry, right?
Sorry.
7F is, yeah, 7F when added to 01, there won't be any carry.
There won't be any
And
carry and overflow will be set. Since
overflow will be set
both are
because
unsigned numbers,
come
the
again?
result will, since both are unsigned numbers 7F and 01, when we add, the result will be 80, which is
Yeah,
a negative number, and our overflow flag should be set.
yes. Sorry, I got carried away. Okay, so not C, it's B. Okay. I have, mm, yep. Now add 7F to FF. What will you get? Anyone?
Carry is 1,
Hmm.
and I have confusion regarding this overflow flag.
Okay, so what is F plus F? Let's do it if we're doing. What is F plus 1?
10, ma'am.
10. You'll have 1 in your result, and there'll be 1 for the carry to the next bit and 0 there. So what will be F plus F?
E, ma'am.
F plus F is E. Yeah, it will be E,
It is
and
E
we'll
with
have
one carry.
with
One
1 carry,
carry.
right?
Yeah, yeah. E.
And so we'll have to add F plus 7 plus 1. What will it
Yeah,
give
yeah.
us? F plus F is giving us E. F plus 8 will give us
17.
17, 7 with 1 carry, which means we have a carry. And since the number, as Ananta explained, uh, it's 7, it's not a negative number, so we won't be having overflow flag set.
Okay, so this means if the number is not negative, then we don't have a overflow flag. Okay, so carry is 1 and overflow
Overflow
is
is
0.
0. Yeah.
Okay, option C.
Okay.
And another point, minor point to add is the
Hmm.
FF in 2's complement, it is -1. So 7F minus 1 is 7E. So whatever carry that got generated, that should be ignored. And the actual answer is, if it is signed addition, then the answer is 7E alone. The carry should be ignored. If it is unsigned addition, then we can include that
Yes,
carry.
but since we're doing, I
Yeah,
mean,
yeah, ma'am.
I
Here in this
yeah,
case, it's the carry flag
yes,
is set in
and
both the
if
case.
and if it's unsigned, it's explicitly mentioned that.
Yeah, we should, whether we should ignore the flag or not, that matters. But the carry flag gets set here, and the
Yes.
overflow is 0.
Yeah. Okay. I think I've answered it. Anyone wants to try? To count n pulses, the value to be loaded to counter your timer or counter register is maximum count being FF. If you want to count, say, n 3 pulses, what value should be loaded to the timer? TH0, TL0, THX, TL, TLX for it to count 3 pulses. Here value of n is 3, and we know that it will count until FF, and after FF goes to 00, which means that is also counted, the timer overflow flag is set, which means we have to load what value? FF minus 3 plus 1, because FF minus 3 plus 1 is FT. In first count, it will become FE. Second count, it will become FF. Third count, when it goes to 00, then timer overflow will be generated, which means FF minus 3 plus 1 should be loaded to the timer to count 3 pulses. Getting?
Yeah, ma'am.
Okay, so C is the correct answer. With that, today's session is officially over. Thanks for joining, everyone. And I'll upload the slides with some diagrams and try to understand and you can ask me questions regarding today's session in next week.
I need to study on this counter, but is it an up counter? That's why you load with the, like if I want to
Yes.
count 5, then if I load with 250T, then
Yes, it's an up counter, unlike the other counters we're used to. These timers, T1, T0, they are up counters.
in up counters, in other counters, whatever we have studied, like it counts from 0, and then it compares with the whatever period value we load. So I
As in?
so if I want to count 5 pulses at up
Mm-hmm.
counter, it always starts with 0, and then it compares with how many number of counts I want to count, and it reaches
Yeah, but here, the way the timers work, they will count until FF.
FF. Okay, and it's an
Okay?
up counter, so you'll have to load
Yes.
max minus. Okay.
You can't end it abruptly anywhere. It will generate the timer overflow only when your timer goes from FF to 00.
Okay.
That is why you have to count it like that.
Okay.
Okay. Okay then. Thanks everyone.
Good night, ma'am.
Happy learning. Good night. Good
Good
night.
night, ma'am.
Good night.
Night.
Good night all.